Okay, let's get to the demo. So, we got to the demo yesterday, so we're going to see how well it works today. So yesterday we were able to use JTAG over the USBC connection to monitor the temperature. And we're going to look at some other features that we can do today. So the four main features I want to be able to do over JTAG in a normal situation would be to do MicroBlaze Debug module. This is important for doing Vitis and debugging the software. We can show you how that works. The internal logic analyzer, when I want to look at something, I can debug things in the block diagram, in the HDL, in the synthesis, netlist. I can pick different objects to identify as debug, and then have Avado place a ILA core on it to observe it. I did one on an Axi bus, and currently it doesn't work, and I think it's more of an optimization issue that we need to move some of the JTAG, virtual JTAG software into hardware to make it better optimized. The BBRAM encryption program, it doesn't work. I think Avado is resetting the FPGA before programming it because it's expecting that the JTAG will exist after it's programming the BBRAM. So I think we may need a custom script or do that through JTAG or through internal BBRAM operation, which we can look at later. I mean, it's not terribly hard. Yeah, we might look at that later. And then dynamic partial reconfiguration using Xilinx's dynamic function exchange. I just got that working a few minutes ago. I mean, I got the bit streams. I'm not sure if it works through the USBC interface. So we're gonna, I guess, test that out and see how it works. So let's go look at how the MicroBlaze debug module works. So first, let's take a peek at the block diagram. This is the one with the PR. So if we look at the block diagram, this debug module in this situation, the MDM, is acting both as UART and a JTAG debug port for MicroBlaze. And this is how Xilinx's Vitis software will load onto the device. Allows you to use their IDE to do breakpoints, watch on variables and memory addresses. So it's very interesting. So first off, if we just let this run, it takes a while to get up and running. So let me move my face real quick so you can see. So the bottom right, we have this debug default configuration booting up. I'm not sure exactly what it's doing. It's kind of slow. Hello, Iberishi. Iberishi. How to say that well. Welcome to the demo. Okay, we're currently loading the ELF file onto the MicroBlaze through the USB-C port. Ignore the JTAG port, it's not being used at the moment. And it works just fine. We are able to test the DDR. We can also go to the debug option, so we'll run this in a debug mode now instead of the normal operation. Oh, and if in case anyone's running, this is our status on our JTAG. This is the length of the JTAG transactions it's doing. Oops. So right here, when you'll see it start programming it. The pink is a great board. Oh, right here. You see all the 1012s? That's it loading the ELF file. Abirishi. Okay, I got that. Abirishi. I can do that. So we got it working. So now, if we go to here and we stick a breakpoint on this incrementing counter, we'll enable breakpoint there. Now, if we run, we'll see on the top right we have the values associated with this system. If we go to the next breakpoint, we see that these values updated. So this is why the MicroBlaze debug module is very useful if you want to do any MicroBlaze in your design. It's going to be critical to debugging it to figure out what's happening and how it works. And we can go ahead and disable the breakpoint and let it run to completion. So there you go. We have the USBC interface JTAG doing debug on this Artix UltraScale Plus. Now we're going to skip ahead to the partial reconfiguration because I already have that set up. So in the partial reconfiguration, I created a dynamic reconfigurable function here in the block diagram. And I created two functions for it. I created a AND gate and a OR gate. And we're going to see if we can first functionally be able to change it. I just tried through the hardware manager. Oh, and here's the partial region it was selected in. I kind of did it far away. I should probably move it over next time. But through the hardware manager, the partial reconfiguration didn't work really well. So we're going to do it through here, which is a little bit more simple of a function. So we're going to take our partial bit, go to our temp folder here. We're going to rename it partial bit 1, pb1. And we're going to go here, we're going to go fpj-f pb1.bit. I want to see this guy. What happens to this guy when we do this? Yeah, killed it. So what's with the partial reconfiguration that's killing it? There must be some. I'm not used to how this new partial reconfiguration works. So yeah, if you use the real flow, so if we go through here and look at the actual flow for there's a dynamic function exchange wizard right here. And when we do this dynamic function exchange wizard, we can select a part of the design and do different reconfigurable modules, tell what type of configurations, what Vivado settings we want, and everything, and it finishes. And that's how we get it. And then in synthesis, trying to think what we could do differently. I wonder if it's doing a reset. So in here under part temp, that's not what I want. We want properties. We have where's our reconfigurable? Wait a minute. Oh, it's under HD. So if we go under HD, is reconfigurable. And if we go to the device, we have our block right there. Click the block parameters. 9% is being used. Properties. Why is it's probably seeing the rectangle in the background, maybe? That is weird. Why is this? Why can't we do partial reconfiguration over JTAG? I guess we'll have to do ICAP for that one. Oh well. So we did partial reconfiguration, but it apparently doesn't work with our JTAG port. FPGA or do JTAG targets 2. Okay, it looks like this timed out. Okay, so it looks like we're too slow for partial reconfiguration and we're too slow for the ILA. So if we go back to our wonderful thing here, we're going to say too slow. So we need to improve our function. But let me go ahead and show you what the logic analyzer is supposed to look like and what ours does. So what we're going to do, we're going to file, open, we gotta close the hardware manager on this one. Hardware manager, close. So let's go show you what the ILA core is supposed to look like. So if we go open block diagram, we'll show you where we've inserted the debug feature. JTAG read console, is that the... You mean like the JTAG terminal? I'm not sure too much about the JTAG read console at the moment. So we've taken the AXI port, the main AXI port of the MicroBlaze, and we've did the debug option right here. And once we do the debug option, the tools will guide us into placing a system ILA primitive here, which will allow us to debug it during operation. So we're gonna go check out the hardware manager real quick and open local. This time we're going to use the Digilent port to program our device. It'll be nice and slow because of options. Okay, so here we have the ILA. Let me show you how useful this is. So it can be hard to debug the AXI bus or different protocols, right? So we have the AXI bus here. We have all the different channels, and when we do this, we get every single channel. And let's pick a read channel, right? When read valid is high. So let's go here. Do read valid. Read valid. When read valid is high, we're going to trigger. It's going to sit there. Now, if we go to over here and we go to targets, we have the target. We're going to do target 9, which is the MicroBlaze, and we're going to read the. We're going to do a memory read of the base port of the DDR. And if we go back here, we can now see those transactions. Right? So if we zoom in, we zoom into where we are, we read the address there. Very slowly though, because apparently we only read one address at a time. So that's how the ILA core should operate. Now, if we close this out and we're going to use the external JTAG over USBC. So this is programming it with our USB-C interface and starting the terminal. And we go to this one, we open the hardware manager, and now we're going to open our virtual cable interface instead of the Digilant JTAG interface. So we can see the system monitor, and we can see that the MIG passed timing. Let's see if we can make the MIG, can we redo the test? Where I forget how you can force it to recalibrate. Looks like it's just doing it on its own. And then we have the system monitor, which is monitoring the temperature and the voltage. Track time to 1 minute, we can see it much better. But if we go back here to the ILA core, this is the same ILA interface on the same bus as the previous system. Now if we do this, so you see down here we have, you look right here every time I click the trigger button. It's running trigger. Running trigger. Let's see. Let's see if we can move this slightly so we can keep track of our this is our bus. Let's raise this a little bit. Stopping trigger. And it fails. Running trigger. Running trigger. Running trigger. Running trigger. Okay, let's try to minimize how much we're capturing. Oh, we're only capturing 2. Refresh rate, 5,000. I don't know. So there's definitely limitations to this internal JTAG port. Okay, so to review, we have that. We need hardware. We need to do hardware improvements. So we've checked that. We did that. We did that. It's too slow. JTAG. Lovato. Function times out. Same thing here. We'll probably need hardware optimizations. Okay, let's go show you the BBRAM encryption. So if we go back here, if you right click here on your device here, you have an option called Program BBR. This is the battery backed RAM, the BBRAM or the BBR. And we have a key right here with a very basic encryption key. Lots and back and forth communication. And it looked like it failed. Let's see if we can open that target. So the proper way it's supposed to look, if we program the BBR key, did that fast? Did you do it? Use key does not match. Okay, so we're going to power cycle the board because we probably got into a bad JTAG state. Hope it didn't do an eFuse option. That would be my worst nightmare. Cool. Programmed. Refresh target. Okay, program here. eFuse key. Clear BRAM. Okay, maybe we have to clear it. Program Properties. What do you mean the eFuse? Register, eFuse, fuse DNA, DNA port. You can't read that, it's fine. I don't know what the fuse thing is about. Timer. Huh. I wonder what's happened. Let's try opening up that window again. Oh. Program, this. Okay, that seemed to work. Or what Xilinx would say to key. Did something happen to our key? Select encryption. Do I need to say BBR? What if I want to do this function right here? Be cleared. That's an interesting error. I wonder if we're gonna let's bleed it dry for a second. Interesting. Okay. That's not our error. Oh, okay. So, if there's other things in the chain, targets, JTAG targets. So, yeah, it looks like it's just because there's multiple devices on the thing. So what we're going to do is, oh, it's not seeing the local one, so we want to refresh the server real quick. I think our virtual cable on the JTAG chain has confused it. Okay, I think we need to reset the hardware server. That's always a fun thing to do. Details. hardware server. So we're going to end task there. Okay, Vitus. Go ahead and close Vitus as well. Now if we open the hardware target again, this will recreate a hardware server. So we now have another hardware server, but it shouldn't have the confusing things on the device chain. Okay. So we need to do a complete restart. You can say of the Vivado tool chains. Processes. Services. Details. How many chromes? Process. I don't think we have anything up. Just to verify. Vivado, let's get a tickle shell up here. If we do XSDB, I want to make sure we're clean on the JTAG targets. Okay, one JTAG target. It's the first device. Okay, let's try it. I think this was the issue that was specified in that form, is that the JTAG chain can get confused on multiple devices. So we're going to clear the BBRAM. Clear. And we're going to program the BBRAM with a key. It worked earlier. Let's see if we can find any more information. So yeah, I think this is the only issue right here. Maybe need to restart the computer. I'll play around with it later. But luckily, let's go ahead and just make sure our device still works. Front panel. We're going to do the first. Pull up our little first guy. Boop, 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 boop. Let's try to do the encrypted bitstream. The encrypted bitstream works. So I think I might need to leave this turned off for a while so it doesn't so the BBRAM clears, or the BBR or whatever. First. Okay, yeah, that's cool. I think we're good for now. So I want to get dynamic partial reconfiguration and the internal logic analyzer to work. So we have two things. What do we need to work on from here? What is next? So we need to improve the HDL around the JTAG, the internal JTAG ports. You probably want to do a FIFO system, FIFOs, for FIFO inputs. FIFO inputs for TMS and TDI, and be aware of byte size. And then we want to do a FIFO output for TDO. And then for partial reconfiguration, recon reconfiguration. We wanted to use the ICAP, or the internal configuration access port. This will be much faster and a better approach in the end. So okay, and then we want to publish to Git at some point, right? Publish to Git. Sad we only really got one working. I was hoping to get the other ones working. Well, thank you for watching. I think we're going to finish early. We did what we set out to do. Hopefully we can look at improving the internal JTAG quickly to resolve this internal logic analyzer. And then probably look at trying to do the ICAP port. That one should be fairly easy. We just connect it straight to a FIFO. So we may be able to just do that for the dynamic partial reconfiguration. Okay. Well, thanks for watching. This will be, only 30 minutes. We'll see. I think the next stream will probably be Monday. We might do one tomorrow looking at the core score